subjects, beginning of this class, in the first lecture itself, I told the optics, the application of the optics has been enlarged, or what I should say, the application, the more application has come after the advent of the laser. So you know already about the laser. So, but again, for the sake of completeness, let me tell you again. So we have one more chapter left. There we have the laser and optical fiber. So laser and optical fiber. In laser part, we will be discussing properties of laser light, and which we have a bit discussed earlier. So we'll continue with that, and then spontaneous versus stimulated emission and different transition process that takes place in the material, as discussed by the Einstein, as told by the Einstein. And then the question might come to your mind that why don't we get laser like photons from all light sources, because the Einstein told that in every light sources there is a stimulated emission. So why don't we get coherent photons from ordinary light? And then the condition of population inversion, and the relation between Einstein A and B coefficients will be discussing, and what are the basic component of the laser, and about a laser like helium neon laser we will be discussing. So moving on, now this question I asked in the first lecture itself, that what is a laser. Now what is your answer today? What is a laser? If I ask this question again, so any answer from you, Sukomal or Abhishek or Hers? Any answer from you? What is laser?
Laser is a device simultaneous atoms and molecules to emit light, sir.
Okay. Or said something? Anybody else? Aditya?
Sir, we get highly
What is
specific
laser?
wavelength. Like in different light sources, we don't get that specific wavelength. We get a spectrum of different wavelengths. But in laser light, we get specific wavelengths according to us.
Good. Okay. Any
A
other answer?
laser
Yeah.
is a source for high intensity light which has specific wavelength.
Yeah. Deep also said that it emits high intensity and with a specific wavelength. Any other answer?
All the, in laser,
Hello.
all the
They will be
Laser is
always
a
coherent,
device
sir.
Yes.
that
Somebody
emits
telling something.
coherent light.
What is the good name?
To me,
I cannot. Ah, Sanchit. Yeah.
yes, sir.
Sanchit said that laser is a device which produce. What you said?
High intense coherent light.
High intense coherent light.
Monochromatic.
Okay. Yeah. Very good. Any other answer from anyone?
sir, in laser, all the atoms that emit light are simulated in the same direction, so the intensity of light is very high because they are in same phase, or we can say coherent.
Good. So I got some answer from all of you. Thanks for remembering. Laser is a device. Yeah, very good. Laser is a device which produce light. Very simple. Yeah, it's like a torch or a lamp. It is the same. It is a device which produce light. But then, what is the so fun about it? Why you are studying and why you are discussing? So it is a device which produce light that has characteristics which are different from ordinary light. Okay. Laser is a device which produce light having some important characteristics which are different from ordinary light. So what are those characteristics? Those are already listed. They are highly monochromatic, they are highly directional, they are coherent, and they have high intensity. Like some of you told that they have a very specific wavelength, but I have a question here. Can we have a laser light with one wavelength? Only one wavelength means monochromatic. Can we have a monochromatic light? Laser light is monochromatic. Yes or no?
Sir,
You are habituated with the
Sir,
MCQ.
till now we don't have. Till now we don't have. I think.
So MCQ answer, yes or no? Laser light is monochromatic? Yes, no.
No, sir.
Yes,
No.
sir.
No, sir.
Yes.
No, sir.
Aditya said no, and so there is one no. Sorry.
No, sir.
Okay, two no's,
No, sir. No, sir.
one yes. Any other yes? Anybody else wants to say yes?
Yes, sir.
Yes, sir.
Yes, laser light is monochromatic.
No, sir.
Yes, sir.
Yes, sir.
Monochromatic.
Yes, sir.
Monochromatic.
Yes, sir. I agree.
Yeah, let me comment. I don't agree. Okay, laser light is not monochromatic. Okay, laser light is not monochromatic. You see, it is written, it is highly monochromatic. Okay, you do not have monochromatic light source yet. Monochromatic light source does not exist. It is possible to explain by using uncertainty principle. You know, Heisenberg's uncertainty principle. There is an uncertainty principle in quantum mechanics. In physics, I think you have already studied it. Heisenberg's uncertainty principle. So maybe I'll discuss other day that by using Heisenberg's uncertainty principle, it is possible to demonstrate that it is not possible to have a monochromatic source of light. Okay, so henceforth, please remember. So I made this quiz so that all of you remember that monochromatic light source don't exist. Monochromatic light source don't exist. So what about laser light? Laser light is, I think I have a diagram, but no, not here. Anyway, so I might have a diagram. No, anyway, so if I plot, the intensity versus wavelength for ordinary light and for laser light, I should have a diagram. Anyway, I have forgotten to include it. So if we plot, intensity versus wavelength, say if I plot the intensity versus wavelength for, if I plot the intensity versus wavelength for sunlight, say I am plotting it for sunlight, then it will be broad so many wavelengths from 300 nanometer to 3000 nanometer. But if I plot the same for a laser light, for example, if I plot the same for a laser light, this will be very narrow. This will be very narrow. If I plot the same for monochromatic light, this will be like this. So I am plotting intensity as a function of the wavelength. If I plot the intensity as a function of wavelength, like you have a source of, say you have a lamp. Now there is an instrument called spectrometer. If you have a spectrometer, you can collect the spectrum. You can collect the intensity as a function of wavelength, then that is called the spectrum. So for ordinary light, say this is a ordinary light. This is our ordinary light. Maybe a sunlight or the light coming from, say, lamp. Sorry. So you have an ordinary light, and this is the case for a laser light. This is the case for a laser light, which has a narrow spectrum, but not monochromatic. And this is the case for, monochromatic light. But we do not have monochromatic light, like your sodium lamp you were using during your Newton's ring experiment. We told that it can produce two wavelength 589.0 and 589.6. So they are very narrow, but still there is a broadening. So monochromatic light will have line type of spectrum, intensity. So all the light sources are not line, they have a curve. So is it clear that laser light is not monochromatic? Clear? Hello?
So how
Yes, sir.
the intensity of monochromatic?
Sorry? Somebody asked Deep, I think, asking
So
something.
how high can the monochromatic light have intensity? Like what's the max intensity have?
You are talking about the intensity is different, it depends on the number of atoms, how many atoms or molecules there is transition. So here I am not talking about the intensity, this is relative spectrum. Okay, so maybe that, like as per my drawing, it looks like it is it's not like that. I make it bigger just to give a feel that yes, this is monochromatic. Okay, so it does here. I have not plotted in terms of the intensity. Definitely, when you go for the laser light, you can achieve high intensity than ordinary light, like a ordinary lamp, because you can focus the laser light to a very small diameter. So you can achieve high intensity the laser light. That is not possible with a ordinary light. Okay, so intensity depends on many other factors. Here we are not talking about the intensity. Here we are talking about the wavelength content. Okay, we are talking about the wavelength content. Intensity depends on many factors, like which material is used, how many atoms are transiting, and what is their emission cross sections, and all these factor affects the intensity. Okay.
Yes, sir.
Yeah. So is it clear that laser light is not monochromatic? So I hope all of you will remember henceforth that there is no monochromatic light source exists so far. Laser light is highly monochromatic. Yeah, laser light is highly monochromatic. So its bandwidth is much narrower compared to the ordinary light. It should be clear to all of us now. And the laser light is highly directional. Like any light ray will suffer diffraction. We have studied diffraction because you will be using part of the light ray, because the light is, say you have a device from where the light is coming. Now the light is coming from an aperture, from here say light is emitted. So this aperture is limited. So definitely you will not be able to allow all the full wave front to pass through. So some part of the wave front will be cut. So this light ray will suffer diffraction. So while traveling, it will be broadened. So diffraction will be inevitable in any light source. Diffraction will be inevitable in any light source. So laser light also has a diffraction, but yes, diffraction spreading is very less. Like all of us, definitely you compare you yourself with your friends. You find that the two friends or the few friends are working together, studying the same way, but one is grasping more, another is grasping less. Now, what is the difference? Your age is the same, you are sitting in the same classroom, same teacher is teaching with the same preference. It's not that PK is preferring Deep not to preferring Ankita or to Aditya. It's not like that. So I have the equal preference to all of you, but some of you is grasping more, some of you grasping less. Depend on your concentration. Somebody is concentrated, highly concentrated for this moment. So they will remember. Once I said, they will remember henceforth. And somebody is not attending, so thinking something else, so thinking about the breakfast today had in the morning, then how you definitely will not be able to grasp equally as Aditya grasps. So it is like that. So the diffraction is there, but in case of the laser light, there is a because of its characteristics of the stimulated emission, it generated by the process of stimulated emission. Now, sometimes if you believe, some people say is that from your birth they can tell everything about you. So like the process of emissions, the process of emission, makes the characteristics. So laser light, is emitted by stimulated emission. So we'll be discussing that in the next class, what is stimulated emission and difference with the spontaneous emission. So the process of stimulated emission makes something different. Okay. So in case of the laser light also, but diffraction will be there. Is it clear? Sabhaji, Sabhabhat, I think. Sabhat, is it clear? Or
Yes, sir.
Sumit? Is it clear, Sumit? Sumit? Yeah, good. Yeah. So there will be diffraction always present in any light source. So laser light also there will be diffraction, but this diffraction is less and it is coherent. And as a result, we can focus laser light to a diameter smaller than human hair. Human hairs are a few hundreds micron thickness. So you can focus the laser light to such small diameter. So you can achieve very high intensity using laser, and high intensity per unit wavelength, because number of wavelength content is very small for laser light. So the brightness, that is the intensity per unit wavelength, is very small for laser light. That's why we cannot look towards the laser light. Never please try, because it will damage your eye, and damage will be irreparable. It is a gift of the God. So please don't look towards the laser light, whatever less power it looks, okay, but its brightness will be very large. So it will create a temperature in your retina, because it will be focused in your retina, and the temperature which will be created in the retina can be calculated, which is sufficient to burn your eye, even milliwatt laser power. So please don't never look towards the laser light. So please remember that whatever less intensity, like laser torches, laser toys you might have used, you have seen, but please don't look directly towards such laser light. It can harm the eye. Yeah, but we are working, like I have did my research with the laser light, with the high power lasers, with the grace of the Almighty, nothing can happen. So if you are careful, nothing will happen, and it helps a lot. But you have to be, use it with proper care. Anyway, so this is about the laser light and its characteristics. Now in the next class we'll discuss about other objectives, like what are the different transition process we'll discuss first, and then we'll discuss about the difference between spontaneous and stimulated, and condition for dominant stimulated emissions and condition for population inversion. This will be discussing the next class. So today, because we are almost nearing to the end of the time, so let me give your attendance, then we'll leave today. So let me stop the recording.